I used to be absolutely terrible at trig equations. And then I learned a few principles and I got a little bit better. But I never got really good. And the reason for that is because I was always missing out on two key principles that is basically the difference between you getting all the solutions and you just getting one or two. And as a result, I was always leaving a bunch of marks on the table. So that's what this video is going to solve for you. I'm going to take you through principle one, which helps you to achieve all the solutions within a trig equation, okay, in as little time as possible. And then principle two is basically going to show you how to combat those difficult part C questions that are often a differentiator between an A or an A star. Alright guys, so let's make a dent in this question. So here we are told to solve for 0 to 360 the equation we just rewrote. Okay, so what they want us to do is solve for 3 tan squared theta minus 4 tan theta minus 4 is equal to 0. So the first step of this is actually quite easy. So what we need to do is basically you use like a k substitution. You don't even have to do that if you don't want to, but I just find it easier. So use a k substitution, and what you'll get is tan theta is equal to negative 2 over 3, or tan theta is equal to 2. Now the reason for that is simply just quadratic equations, right? So 3 times negative 4 is equal to minus 12, and that can be broken up into minus 6 and plus 2. Okay, and what that allows us to do is to break up the negative 4k into negative 6k plus 2k, okay? So pretty simple there. That's just quadratic equations, right? That's GCSE stuff. So the next phase is to say, well, look, k is equal to negative 2 over 3, or k is equal to 2, which means that tan theta is equal to negative 2 over 3, or tan theta is equal to 2. So now we have some interesting curveballs here. Okay, so you're not going to want to skip ahead because this part is really important. We have tan theta is equal to 2. So let's do that first. When tan theta is equal to 2, what do we get? Well, when tan theta is equal to 2, what we get is 63.4. Okay, so that's great. We've got a positive here. So if we draw a cast diagram now, we know that we're going to lie in the quadrant where tan is positive over here, and where all the angles are positive, which is obviously in the A quadrant. Okay, so what does this mean for us? Well, here comes principle number one, okay? And that principle is, because we have a positive, because tan theta equals a positive, our reference angle, which is 63.4, okay, we can use that as a solution, okay? You can't do it if it's negative, and you'll see that in a second, but you have to watch this bit first. So 63.4 is our first solution. Great. Okay, now our second solution here is going to be 180 plus 63.4. So that's 243.4. Cool. Now this is where things get really interesting, because we have a negative. And as I said before, we can't use a reference angle as a solution when we are working out a negative. So what do? Well, what I'm going to say is, let's draw a cast diagram. And as you can see, we have tan theta is negative when we're in the S quadrant or the C quadrant, okay? So we have these two quadrants where we have tan is a negative, right? But I'm going to pretend, okay, that tan theta is positive, just in the sense of, I want to go to these triangles and just say, let me just work out theta within these triangles, okay, just for argument's sake. And when we do that, we get theta is equal to 33.7, which means what? Well, that's now going to be our reference angle, but it's not going to be a solution. And it's not going to be a solution because if you plug that in to the original equation, you're not going to get the answer you want, okay, which is 0. And so what you want to do here is you're actually going to want to minus that 33.7 from 180. Okay, so as you can see, because we lie in the S quadrant, we minus it from 180, so we get 146.3. Okay, and then in the other quadrant, we're going to minus it from 360, so we get 326.3. And as you can see, these are all our solutions that are possible in the range of 0 to 360. But we're not done yet, guys, because as you can see, for number C, that is a tricky question that's going to trip a lot of people up. So the question becomes, what principle do we need to solve this problem? Well, the core principle here, guys, is the fact that we have the same question just written differently. Here's what I mean. Before we had to solve between 0 and 360, okay, and now what we have is alpha being between 720 and 1080, okay, and what does that mean for us? Well, 4 alpha is going to be between 2880 and 4320. Okay, so really what's going on here is it's the same equation, but the angles has changed. So what we need to do is we need to first think to ourselves, okay, 4 alpha, that is between 2880, okay, and 4320. So what does that tell me? Well, considering it's the same equation, guys, obviously our x value, okay, because it wants the smallest x value, our smallest x value between 0 and 360 was 63.4. So we're going to be using that. But the key thing is, considering it's the same equation, okay, just stretched on the angle side, that means that for 4 alpha being between 2880 and 4320, what we need to think to ourselves is, okay, what needs to be added to 63.4 to get us in that range? And what needs to be added to 63.4 to get us in that range, okay, is going to be 8 times 360. Because remember, what we have here is a periodic cycle, okay, of 360 degrees. So as a result, 63.4 plus 8 times 360 is then going to give us 2,943.4 degrees. But remember, we're not done yet, because 4 alpha is equal to 2,943.4 degrees. So as a result, alpha, and therefore our answer, is going to be 735.9. So there you have it. Those are the 2 key principles that you need to basically get your head around any kind of trig equations you'll ever come across in A-levels. The first thing, okay, is the reference angle, and remembering the principle that the reference angle for positive is going to be a solution, but for negative it's not. Okay, and the second thing is, and there's part C questions, you just got to remember that it's the same equation, but we just have to account for the range, okay? And we just have to be smart about the way we approach it, okay, be logical about the way we approach it, but it's honestly not that big of a step up from what we've already done, hence why it's 1 mark.